Hey folks, here's another example dealing with parametric equations. Didn't have time in class, so I thought we would do one more here where we will sketch parametric equations and also look at eliminating the parameter. So we're going to look at this set of parametric equations. X equals t squared minus 1 and y equals t cubed minus t. First thing we're going to do is we're going to sketch the curve given by the parametric equations, and then we're going to write this into the parametric equations into a rectangular equation. Keep in mind when we sketch the curve, we'll want to um, make sure we have the correct orientation of the curve. So here we go. I trust that you will have your calculator out. You'll get it fired up. Keep in mind you're going to enter this when you hit your y equals button. You should be in parametric mode. So when you hit your y equals button, you should see x1t and y1t. So you put this in x sub 1t, and that's in y sub 1t. Remember your variable button is the t button. So once you get that entered, also remember to hit your window button to take care of your viewing window. And I would start off by using the standard viewing window for the x-axis and y-axis. For a t range, by default, I'll just start off having a t min of -5 and a t max of 5. And I like to have my t step be a 0.1. And this is the graph I get when I do that. And -10 to 10 on the x-axis and -10 to 10 on the y-axis. And when I did the graph, this was the orientation. I saw the graph come in this way and then head out that way. So we have to make sure to put our little arrows on there for the orientation. I have a little trouble seeing exactly what's happening right here. So I'm going to redraw the graph with my graphing calculator, but I'm not going to use such a large viewing window. I'm going to make a smaller viewing window so I can kind of see what in the world is happening right here. So when I regraph it with a smaller viewing window, my x-axis from -2 to +2, and my y-axis from -2 to +2. And I kept my t's the same in the viewing window. I kept the t values, t min -5, and a t max of 5, and a t step of 0.1. Now I can kind of see, there's a little loop here. And make sure I get in the orientation of the graph, that it came in this way, and then it looped around, and then it went out that way. So that's quickly how to sketch a curve. It's very friendly now that we have technology that will do this for us. A lot easier back than when I learned how to do this stuff. Making a TXY table was not fun. For part B, we're going to take the parametric equations and we're going to rewrite it as a rectangular equation. Now we did a couple of these in class. I think the first one was rather straightforward because it was linear. Both the x and y components were linear, and it was easy for us to solve for t and substitute into the other one. And I think the other example that we looked at in class involved trig functions. So we were able to make use of our trig identity. Cosine squared theta plus sine squared theta equals 1. This one isn't nearly as straightforward. X equals t squared minus 1, y equals t cubed minus t. I kind of look here, and it's like, well, if I factor out a t, I'm left with y equals a t times a t squared minus 1. And, well, here's a t squared minus 1. But I would have that t. I would still have a t that would be causing me problems. So here's kind of how I'm going to start this one. First, I'm just going to take this and just add 1 to both sides to get an x plus 1 equals t squared. And then I'm going to go ahead and factor out the t. over here to get y equals t times the quantity t squared minus 1. So yeah, I can see right here is an x, but I still have this problematic t here. I can't just put an x in here and then have a t. I will not have converted to a rectangular equation because I'd have an x, a y, and a t. Well, here's a little trick. I mean, well, it's kind of a trick. Um, Square both sides of this equation. If you square both sides, you get a y squared equals a t squared times the quantity t squared minus 1 squared. And now you kind of see t squared minus 1, that is x. This t squared here, well, that's x plus 1. So if we go ahead and just substitute x plus 1 in here for t squared, and x in here for t squared minus 1, that will give us the rectangular equation y squared equals x plus 1 quantity, and that quantity times x squared. And if you'd like, you could distribute that x squared. I'm not going to. I'm going to put the 3 dots in, meaning we are done. Final comment. I know I mentioned this in class. Let me mention it again. Please make sure you read page 713 and example 2, which I believe is on page 713. It deals with taking a parametric equations and converting them into a rectangular equation, but you have to adjust the domain for the rectangular equation. So please read that example. I hope this extra example has proved beneficial. Thanks for watching.